according to the dyes deposited on top of the our substrate, and it gives 5 opium dye is 5 and photocurrent enhancement is 20. And curve B shows the after introducing carbon nanotubes. I'll explain it next slide. This is our next process is carbon nanotubes depositing on top of the our PN junction and dye on top of the dyes. This is before I'm going to explain process. I briefly explain what is the carbon nanotube. Carbon nanotube is high aspect ratio carbon nanomaterial family included to graphene. Nanotubes can be divided into a single wall nanotube, double wall nanotube, or multi-wall nanotube. Properties of the nanotubes are highly conductive, thermal stability more than 600 Celsius, lightweight, and hardness more than 100 times of steel. This is the carbon nanotubes deposition process. We used doctor blade method to deposit carbon nanotubes on top of the our substrate. Then after including carbon nanotubes on top of the our PN junction cell and dyes, carbon nanotubes interlock with this dyes and enhance the photocurrent generation. This is the interlocking after interlocking dyes and carbon nanotubes. Then when photons dyes absorbing photons and it generates electrons, then using carbon nanotubes is superconductor, and it move electrons and enhance photocurrent generation. This is the process of enhancement of photocurrent using carbon nanotubes. And then diffuse reflectance spectrum. I also explained curve A and B according to the NCU2O, and after including PCI on top of the NCU2O and create PN junction. Then curve C shows the after including dyes on top of this PN junction. Then we can see clearly absorption peak appear according to the 530 according to the 60 according to the dyes, and that curves little bit move to right side after enhancing synthesis carbon nanotubes on top of the that electrode. Then photocurrent action spectrum, curve A shows the photocurrent action spectrum according to the NCU2O. Then curve B shows the photocurrent action spectrum for PCUI. Then we make PN junction. It shows the curve C, and after including dye on top of this PN junction, it shows the curve D, and after introducing carbon nanotubes, it shows the curve E. And we can see clearly photocurrent enhancement will appear after introducing dyes and carbon nanotubes. One peak appear according to the 400 nanometer. It for NCU2O, CUI, PCUI. Then after including NCU2, it peaks appear according to the 550, and after introducing carbon nanotubes, it appear on the dyes, it appear 580. This is the VI characteristics of our cells. Curve A shows according to the PN junction, and photocurrent conversion efficiency is 1.5%. Then after introducing dyes, photocurrent enhancement is 2.5, and after introducing carbon nanotubes, photocurrent conversion efficiency increased to 4%. Then we will move to time development of the photocurrent. This is the time development of the photocurrent. Curve A shows according to the PN junction, and curve B shows the after introducing dyes on top of the PN junction, and curve C shows the after introducing carbon nanotubes on top of the dye. Then we can clearly see stable photocurrent appear according to the cells, and it increases after introducing dyes and carbon nanotubes. Conclusion is the photocurrent enhancement can be found after introducing dyes on top of the PN junction, and then further enhancement can be appear after adding CNT on top of the PN junction and dyes. And photocurrent enhancement can be explained using Kahn's model equation, and explain new model for enhancement of photocurrent through CNTs. Finally, I acknowledge General Surgeon Kotalawala Defence University to give this opportunity, and National Research Council for giving grant Nano 26. Thank you, sir.
And thank you also for finishing it within time, allocated time. Thank you.